So I'd like to talk briefly about some summaries, some shortcuts for determining whether an nth root is a real number or not a real number. If we look back at the remains of the recording from the previous part, we had really four different cases. We had the case when we were taking the third root of a positive number, the third root of a negative number, the fourth root of a positive number, and the fourth root of a negative number. And in one of these cases, the result was not real. It was not possible to find a real number whose fourth power was negative 16. Now, to summarize some of the thought processes there, let's go for the following table. Determining whether an nth root is real or not real, and here are our four different cases. If the index is an odd number, like 3, the result of taking an odd root, this is always real. Let's try again. If the index is odd, the root is always real, no matter what. Whether you put in a negative number or a positive number, you can find something whose nth power is your radicand A. It's only when the index is even that things begin to become more delicate. So if you have a positive radicand, still no problem. But if you're trying to take an even root of a negative number, this is the only case where you start to have some difficulties. If you're taking the nth root of a negative number, the result of that is not real. So this is the only case in which the root is not real. Now, just as a point of warning, nth root of A can be a real number, even if it's not a nice number. I should say even if it is not nice. So for example, something like square root of 10, or if you prefer, the second root of 10. This number is not nice. If you go and plug it into the calculator, you get this big long string of digits. But the fact that you could get digits from the calculator is enough to say that this number is real. If this number were not real, the calculator wouldn't know what to do with it. This is real even though it's not nice.